Today we're going to go over 7-1 or 7.1 parabolas. So let's talk about the analyze and graph parabolas. Now I will not require you to copy down all the information, but let's talk about conic sections. Conic section, or also known as conics, are the figures formed when a plane intersect a double napted right cone. A double napted cone is two cones opposite each other and extended indefinitely upward and downward, meaning extended infinitely. The four common conic sections that we will be covered in this chapter are the parabola, the ellipse, the circle, and the hyperbola. Now, you don't really have to write down the whole information, just the basic. And I'm not going to require you to have this pictures in your notes, but it's an illustration of what it will look like on a graph. Here, when it's talking about the plane, it's talking about the beige rectangle square plane that you can see right here within the picture that is intersecting or cutting through the conics. So here, the way how you see this plane is intersecting the conics, it will represent the circle that's in the middle where it's cutting through. Now, if you look at the plane, the beige, light brown plane, you see how it's slanted? So when it's intersecting the conics at a slanted angle, it will form an ellipse. Now, the third one here, the plane is intersecting the conic section at a different angle, but also at the bottom part where it will form a parabola, so like the U shape on a graph. Now, in the fourth one, where you see the plane is intersecting both the top part and the bottom part, or both ends of the conic sections vertically. Now, this can still be applied horizontally, depending on how the conic section is oriented. Now, you see how it intersected the both ends of the conics? So then the intersection where the plane is intersecting the conics, there's going to be two parts of it on the graph. Now here you don't have to worry about the second part of the information from the book. We're going to move on to this basic information here. All right. The general form of the equation for conic section is ax squared plus bxy plus cy squared plus dx plus ey plus f equal to 0. This will always be the general form of the equation. The reason is that we have the variable x and y when we're doing the equation for circles, parabolas, ellipse, and hyperbolas, because you will be using both those variables and they will have exponents on them when we are writing the equations from parts, given information from graphs, and an event where you would have to graph using the given equations. So you will see that where x and y will have exponents. To talk more in depth of the general form, a, b, and c cannot all be 0. More specific algebraic forms for each type of conic will be addressed as they are introduced. So the next given information here will relate to this graph shown on the right. A locus is a set of all points that fulfill a geometric property. A parabola represents the locus of points in a plane that are equidistant from a fixed point, called the focus, and a specific line called the directrix, or directrix. Now, to put locus in layman's term is basically points that you plug in, like x values to get y values, or y values to get x values. And basically you plot the points. Now, the parabola is the blue line right here. Now the focus is right here. Now to determine the focus it's always aligned with the vertex. You see here, this is the vertex right there. So it's always going to be the equal distance from the vertex when you have the information with the directrix. So let me go more in depth with that. A parabola is symmetric about the line perpendicular to the directrix through the focus called the axis of symmetry. The vertex is the intersection of the parabola and the axis of symmetry. Previously, you learned the quadratic function f of x equal ax squared plus bx plus c, where a does not equal to 0, represents a parabola that opens either up or down. The definition of a parabola as a locus can be used to derive a general equation of a parabola that opens up, down, left, and right. So what it means that in Algebra 2 and previous sections, you see a parabola only opens up or down. But here in this section, you will see that it can be opened up, down, left, or right. So we don't have to worry about if it's a function or not. We're just going to worry about the equations of the parabola. And the same thing would apply for circles, ellipses, and hyperbolas. Now, the red horizontal line, that is the axis of symmetry. It always goes through the vertex of the parabola. And it was talking about how the axis of symmetry is always going to be perpendicular to the directrix. Now, we know that the directrix will always be near the vertex. So if you take a closer look, here's the directrix and here's the vertex. How it's related to the focus is that the distance between the directrix and the vertex will be the same between the vertex and the focus. So, for example, if you have the information of the directrix and the vertex, you can find your focus. If you have the information on the focus and the vertex, then you can find your directrix. So that's going to be part of it when you're trying to find the equation or when you're graphing. Now the focus will help you find points when it comes to graphing or forming an equation. And then sometimes you might have to use locus, which is the points, such as p of x comma y. So we're going to go more in depth with the equation in the next video, but this is basically the gist of it. Now here you are not required to copy down all the information, except for the ones that highlighted. I would recommend you write the definition of parabola, focus, directrix, axis of symmetry, and vertex, and especially with the general form of the equation. I would also recommend to have this picture in your notes to have a general or basic idea of what the parabola will be when it comes to graphing and when it comes to writing the equation.